Hey, good afternoon, everyone. How y'all doing? Good? Little food coma, post-lunch cookie wrap. All right, so quick introduction about myself. My name is Alex Liu, and I'm an engineer at Netflix on the UI platform team. So our team basically stewards the Node infrastructure at Netflix, and we're currently in the process of actually building out a Node.js-based PaaS for our UI organization. So that's pretty exciting stuff, but I know we've been hearing a lot about containers today, so I'm not going to go too much into that. Instead, dig a little bit deeper into JavaScript specifics today. So I figured this is just something equally important for folks who are working in JavaScript. So today, I figured we'd talk about errors. And I thought I'd start off actually with a short story about what I think is one of the greatest errors in human history, which is the destruction of the Library of Alexandria. So the library was founded in the 3rd century BC, and it's hard to have exact numbers now, but at the time, it was estimated that the library had probably 400,000 something scrolls. And so it was rightly considered to be the leading intellectual metropolis of the Hellenistic world. So as a research institution, the library was filled with works in mathematics, astronomy, physics, natural sciences, and many other subjects. Now, unfortunately, as we all know, peace never really lasts very long in the ancient world. So civil wars and power struggles, eventually, including multiple acts of destruction, saw the library kind of just simply fade away over the years. So in history, the library has come to become a symbol sort of for the loss of cultural knowledge and potentially one of the greatest singular losses of knowledge that we know of today. So as humans, we have a great desire to learn and really to want to do things right and to learn from those that came before us. And nowhere is this more applicable than software, right? Where mistakes that we make are often represented as bugs or errors in our code. And that's okay, right? Like we all have bad ideas and we all make mistakes and we all make bad assumptions from time to time. And if anything, history has shown us that we generally have more bad ideas than good ones. And the context for this picture here, for the folks that don't know, there's a fresco here in a Spanish church that was deteriorating due to moisture over time, and one of the good parishioners kind of took it upon herself to do a restoration. So good intentions, right? But like I said, we all make mistakes, and what's actually important is learning from these mistakes and learning to deal with them. And to be really clear here, when I say we should learn to deal with errors, what I mean is not avoiding them, but rather accepting that errors are going to happen, right? As with many things in life, acceptance is the first step to happiness. And so whether you like it or not, errors are an important part of building software. And so only after you choose to accept this fact can we truly begin to build robust and reliable software. So to get us to that state of happiness, we'll cover a couple things today. So first, we'll talk about errors and exceptions and sort of what the difference there between them is in JavaScript. And then we'll take a look at how we can build some rich error objects. And finally, deep dive into what I think are some problems with try-catch as they exist in the JS spec today. So together, hopefully, after these sections, we'll be able to avoid any potential fires to our production applications. All right, so first things first, what is an error? So I think it's really important that we're clear about the terminology because these concepts don't always translate one-to-one from other languages. So in JavaScript, an error is an instance of the error class. And so there are actually two kinds of errors here. You have what we call expected errors, and they're also known as operational errors. So these are runtime errors that your application or your system should know about. So an example of this with which everybody should be familiar with is invalid input. So getting invalid input from the user is expected, and you should be able to handle that. And if you're talking to external service, getting timeouts or 500s should also be expected. Now, the other kind of error here is an unexpected error. So these are better known as programmer errors. So as their name suggests, they are more or less bugs in your code. And these are much more insidious, right? Because unexpected errors typically occur as a result of programmer errors. That means in 99% of cases, you can't actually handle these properly. So once you've got an error object, how do I actually communicate this, right? You can't always handle errors at the point that they're generated. So for example, if your program fails to read a file off disk, you probably don't want that to fail your program or to crash that program, right? Instead, you want to bubble that error up to something else that knows how to handle it. And so one way is to throw this error, right? And throwing an error creates an exception, the way that we kind of understand it in other languages. Now, technically, you could throw anything, or you could throw strings, you could throw numbers, you could throw nulls if you wanted to, because, hey, JavaScript, right? But a thrown string is not actually an exception. And were you to ever throw something that is not an error object, you should just walk outside, take a deep breath, sit down, and think about what you just did, because somebody, likely your coworker, is probably going to be cursing your name under their breath. And so why is this so bad, right? Like, what's so bad about throwing a non-error object? It's bad because you don't get a call stack, you don't get an error name, and you don't get anything useful that actually tells you what happened, and there's no information there to help you track that down. So if you do throw something, make sure that you're throwing an actual error object. And so let's kind of visualize what that looks like. Maybe you've got some code here that calls down a couple of different layers. And then maybe inside your get call, you throw an error, and that exception is created. So that exception is going to basically bubble back up through all your files, looking for a catch clause until it finds one that exists. And when it finds it, then great. Like, you catch that error, and then you do something to handle it. And of course, as expected, if you don't catch this error, then the exception will crash your process. So in practice, from a code perspective, this is what that might look like. So we've got a function here that retrieves a stock price. If that method happens to throw an exception, then you can catch it here, decide to handle it gracefully, and handle it accordingly. So let's look at another common scenario here, where catch might not work, right? So here, getStockPrice is now an asynchronous function. So we call, and we get potentially some return value here. In our callback here, we get an error. So what we're going to do here is now throw that error and then attempt to catch it. So who's done this before? Or who's tried to do this before? One person? Two? That's it? OK. I've done this before. The rest of you are all liars. Because I know anybody who's worked in JavaScript has done this at some point in their career. So since nobody has done this before, you can all tell me what's wrong with this, right? Why doesn't this work? So the reason that it doesn't work here is because it's asynchronous, right? You can't try catch code that's being executed in a different event loop tick, which means that that thrown exception is just going to bubble up and then crash your process. So to handle this scenario, the concept of error first callbacks were created. So the idea behind error first callback, or an errback, here is that you communicate this error through a callback by passing it back as the first argument. So you can think of it as a lot like a return code in languages like C. So this pattern has more or less become the de facto standard for working with asynchronous Node and JavaScript APIs. So if you get an error object back, then you can handle this, right? And as we talked about, timeouts or 500s from external services are things that we expect, and you should handle them. So just like our original try-catch scenario here, in the case of an error being returned, we can check to see if an error exists, write some other content to the page if that happens to be the case, and return early. So great, this is cool. Now our UI happens to be able to handle both happy and unhappy paths. Now you can't always handle these errors where they are, right? Just as with try-catch, you need a way to kind of bubble that error up. So in this case, if your getStockPrice function happens to be encapsulated inside another function that's being called by someone else, sometimes the best that you can do is simply return that error to the original caller and pass it back up the chain. So if we were to visualize this error-back chain, just like we did with try-catch, it's pretty similar, right? Like, you have an error that gets passed all the way back up to somebody at some point who knows how to handle this error. Except there's one major difference here, right? You need to be very explicit about both passing that error along if you can't handle it, but also handling that error at some point, right? If you don't do either, then that means that error object gets effectively swallowed. And because we have to be very, very explicit about this, right? This is both the passing and the handling of this error object. Errbacks in and of themselves kind of become a channel for expected errors. So what that means is, unlike exceptions, errors passed to your callback do not automatically crash your process, right? So that means for every error object that you've ever returned or you've ever received from an API that you've called, if you're not explicitly handling it or returning it back up to the original caller, then that means you're swallowing that error. And that's a very bad thing. Cool. So everybody who's worked in a lot of JavaScript is like, yeah, sure, that's great. I totally get it. You're preaching to the choir. If we're synchronous, then you can use try, catch, and throw. And if you're async, use your errbacks, right? And that all seems to make sense and seems pretty straightforward for the most part, right? Well, not exactly. Um, as it turns out, while this works for really small modules and small surface APIs, when it comes to building really complex single-page applications, it can make things exceptionally difficult to reason about. And this might have worked in other languages. And if you think of something like Java, where everything is, quote, synchronous, you can basically try catch everything under the sun, right? But in JavaScript, where 90% of the time you're frequently doing something that is asynchronous, then what that means is you don't actually know all the time whether or not you're in a sync context or in an async context. And you can't really make any safe assumptions about that context that you're working in. And so you don't even know whether or not a try catch would work in that particular scenario. And because we do work in such a highly asynchronous environment, what that means is that you should favor urbacks because they provide a lot of consistency across all of your error handling. OK, so we've covered expected errors now. So what about unexpected errors, right? How do you communicate those? Well, because they are unexpected, they are thrown automatically, like we talked about, right? So everyone should be pretty familiar with this, right? You make a typo in your program, you run it, and oops, like it crashed, right? Or it caused an error. So you could just try catch these like expected errors, right? But what happens if you had a typo, say, in some code that was async, right? How do you catch that? As we just saw, you can't really use try catch to catch any errors that are asynchronous. So if unexpected errors are automatically thrown, then what options do we have here? So as it happens, we do have these what we call global exception handlers here. So in Node, we have a process uncaught exception handler. And in the browser, we have a similar window on error event. So this seems pretty awesome, right? Seems really convenient. Like I can just add these things to my program and then suddenly catch all the unexpected errors that I have in my application. Well, turns out this is a pretty bad idea. And if you use it, I'm going to revoke your JavaScript card because these global handlers, while they do have their uses, they're really not meant to be used as a catch-all to handle your application errors. And in fact, of 99.9% of cases, you really don't want to handle any of these unexpected errors. So let's take a look at why that's the case, right? So here we've got some code. So I hope everybody can kind of see this, but basically we've got a function here, right, which takes an array of callbacks. So we've got an array of functions that we want to execute. So there's a couple places where errors could be thrown here, right? So in the first case, we're basically validating input and saying, hey, did you give me an array? If not, I'm going to throw an error. And that's fine and dandy, right? The caller can catch that. In the second case, again, we're checking for bad input. We're saying, did you actually give me, is everything inside this array and actually a function? If not, I'm going to throw an error again. Now, we get to number 3. And in this place, this is where we actually start using this input in an actual executing the input that you've given us. So we're looping through this array and executing each of these callbacks that you've given us. So if an exception occurs at this point, right, we're actually pretty hosed because we don't know, A, how many callbacks ran right before one raised an exception, and B, worse yet, what side effects these callbacks may have caused. So if these callbacks are user supplied, then you actually have even less confidence about the current state of your program. But let's say that we did try to try catch this thing, right? So we put a try catch around each callback before we invoke it. When we do catch it, we actually have no idea what it is that we need to do here, right? Like, are we backfilling values here? Are we, like, there's really no way to safely proceed from here. Like, what if that try block happens to touch some shared state, right? And how far along did we get in that try block before something actually failed? And one thing you have to remember is that JavaScript runs in this globally shared mutable sandbox, which means that there is zero guarantee of both isolation and immutability within your program. So there's really nothing you can do here unless you're coding so carefully that you're essentially able to roll back your application state at any point in time. So great, let's assume that you are a superstar and you built this rollback mechanism. So every time that you run into some unexpected error, you're able to somehow magically roll back program state. But to draw an analogy, right, what happens when your rollback mechanism throws an error? Do you roll back your rollback? Like, how far does it go? Where does it stop? And by definition, unexpected errors are unexpected, right? So while you might be able to guess at the types of unexpected errors that could be thrown, you can never know at the point that they're thrown why they're thrown. And because you don't know why, you can't safely recover from this. And so trying to fix unexpected errors is a bit nonsensical, right? If you try to fix them, you'll probably end up in a place where you really have no idea what's going on, as this picture demonstrates so perfectly. And if, for example, like, we're use a real-world example here, if gravity suddenly stopped working, right, then all of our assumptions about life here on Earth would basically be thrown out the window. And it's the same way with broken code. So in Node.js, your safest course of action really is to abort the process ASAP and restart it. Aborting will allow you to generate a core dump, and then you can easily root cause that process offline. Now, to be super clear here, the goal is not to get you to write bug-free code, right? That is in and of itself an impossible goal. And instead, the goal is really about minimizing the blast radius. So if you think of a real-world example where a train might have gone off the rails, right? Once it's gone off the rails, then what we do is try to, as quickly as we can, safely stop the train and prevent further casualties. We don't keep the train running, hoping that it'll somehow find itself back onto the tracks. And so those with experience running, potentially large monolithic applications might be balking, like, what do you mean, like, I should take down my application, right? Like, if I take it down, it might cost me maybe like 10, 15 minutes just to bring it back up, especially if you've got like a really big honking monolithic application. So yes, like you can choose not to crash when you have an unexpected error, but you have to understand that you are making a trade-off here, right? You'll gain application uptime potentially at the expense of either one, faulty behavior due to some corrupted state, or two, faulty behavior that is hard to root cause because you don't know if that faulty behavior is actually a bug or faulty behavior because you now have corrupted state. Now, some of you might be thinking, well, what about the browser, right? For those of you who write JavaScript in the browser, this is something that we commonly see. Like you're doing something, processing your data, oops, an error was thrown, but hey, no big deal. I'm just going to keep on doing my thing here, and oh, crap, another error. But it's fine. I'm just going to keep on going. And I'm not going to lie. I think this behavior is kind of broken. In just about every environment, in every runtime, unexpected errors crash your process and stop the program. And browsers, however, by default, do the opposite. Instead, what they do is they catch your errors and then keep your JavaScript running. And I get it. I understand the motivation because back in the day when dependency management was really just attaching a script tag onto your page, you didn't want third-party scripts to crash your application, right? But rather than assume that this is the default behavior, and that this is the thing that we should aspire to, I think we should be clear that this decision comes with some serious trade-offs. Because all the problems that we talked about with unexpected errors still apply to the browser as well. And so if we were to push our previous analogy a step further, right? If your program has an error, then it crashes. I'm pretty sure everybody has seen this at some point with their browser, right? Chrome's going to crash and all your tabs disappear. So what happens when your operating system has an error? What does it do here? Kernel panic? Blue screen? Yeah. And it's the right thing to do, right? Because I know I don't want my operating system to continue on an unexpected error and potentially corrupt my user files or my programs, right? So if that's the case, then why are we doing it in the browser, right? What makes the browser so special that the rules don't apply? And I'll tell you my answer, which is I really don't know. Arguably, as we build more and more complex single-page applications that maintain a ton of state, there's no way to guarantee that your app isn't in a bad state once some unexpected error has occurred. So that being said, since we don't actually have any other choice in the browser, your best bet is to store your unexpected errors and find ways to report those back to a remote service later when the app is in a good state. So you should consider these errors breaking bugs and to fix them immediately. And so to reiterate, avoid the use of global exception handlers as a lazy man's error handler, and instead, use it as a way to log and store errors that you should be handling. And if you're a node, use it as an opportunity to also restart your application. So rolling with the theme of humans making awful mistakes here, this painting here is of Achilles during the Trojan War. So in the 1800s, some dude, he happened to stumble upon the original location of Troy, and he wanted to start excavating, right? Little did he know that the archaeological site was kind of over the years, it was like 9 different versions of Troy kind of layered on top of each other. And so in his haste to kind of like find these legendary treasures, he basically used dynamite to start excavation. So unfortunately, in his haste, like he basically destroyed the city he was actually looking for. So to this day, it's still considered one of the most destructive excavations ever carried out. And clearly, preserving history is important. And so we want to avoid doing what this guy did, right? So let's look at ways that we're able to build error objects that can provide rich contextual clues as to their origin, as well as the code paths that they've traveled. Cool. So our friendly Greek warrior Achilles here, imagine he wants to use the internet. It's cool. Mythical Greek heroes want to use the internet too, right? So he goes to his favorite website, which is the Library of Alexandria's website, which was actually, by the way, rebuilt in 2002. And he goes and asks for something, right? And it comes back, and yay, he's gotten like his favorite book here, which is, I guess, going to be Homer's epic, the Iliad, as soon as it comes up. Cool. So let's work backward from the innermost service here, and imagine that this is code at your data service layer. Right, so we're retrieving something from the database here, and we say, hey, get me the Iliad, and I'm going to get, as in my callback, I'm going to get either an error or the data that I'm looking for, right? So this seems pretty straightforward, but I think we can do a little bit better than this, right? Especially when it comes to the error context. So it might be useful to add some data to the error object. So in this example, we're adding some additional messaging as well as a timestamp. And so this is becoming a pretty standard practice as well as a way to add additional context to your error object. But I think we can do better than that. So there's a module in the NPM ecosystem called VError. And here, as you can see, we can actually create a new VError by giving it an argument of an existing error. And so what that means is, in effect, we can build chained error objects that all retain their original histories. So if we were to console log these objects, right, well, the first one is the regular error, and that looks pretty familiar, I think, to most folks. But you'll notice that the VError object here has wrapped some extra properties, right? So you'll notice that there's a nicely concatenated error message and a bunch of other things that may be useful. So VError objects also have a cause method, which is what lets us programmatically get at the error that was the actual underlying cause. And so what that means is when we use a compatible logger, something like Bunyan, right, what we get is this really, really long and really nice stack trace, right? You can kind of look at this here and say, oh, like I see that my database call failed because I had a missing key, and that was caused by some other error underneath that, which might have been caused by some other error underneath that. But I think we can actually take this a step further and do even better. So there's another module here called Rectify Errors, which is actually built on top of VError, and allows you to easily create custom constructors, right? So as an application owner, you may have different types of errors that you care about. And as you can tell from the constructor here, I can say, I want to create a custom error here called database error, which is always going to have some set of properties. And so here, we can create an instance of this database error. And what's pretty great about this database error is you can see the class lookup chain is all working, right? So this database error is an instance of error. It's also an instance of VError and of your own custom constructor. So, OK, I know some of you are probably thinking, hey, like this is JavaScript. Like we don't have types. Like why do I care about types? It turns out there's a pretty good reason for having them. Because what it means is that we can use this type and basically use these classes to determine how we want to handle different types of errors on a as-needed basis. So in this example here, where we make a request and that request fails, what we can say is like, hey, based on the error that was returned to me, I can potentially handle it differently or give the users a slightly different experience based on that error. And yeah, it turns out Bunyan also knows how to work with rectify errors here. So this is pretty great. I know the text is small, but basically we've got 4 errors here where the first error says, I had a problem rendering a page which was caused by a data validation error, which was caused by a request failure, and finally that was caused by an HTTP 400. So this is pretty awesome, right? Because that means like if I'm running something in production, I can actually look at this log and know exactly what happened. I can know all the different files that it went through, all the different code paths that it traveled, all without opening my debugger, right? And this is super important, especially if you're running servers, running services on Node.js, because you can't really just fire up the debugger in production and figure out what happened. And so if you compare that to an arbitrary error object here that you created with no context and no history, well, short of grupping the code base, like it's pretty much next to impossible to figure out what actually happened here. But hey, thanks for letting me know that something happened. So always use typed errors if you can. And then if you have an error that's specific to your application that you want to handle, then create a custom class and use that to basically provide more context for your application. Now, one note about the Restify errors module. So even though it's called Restify errors, if you're using Express or Happy or any other Node.js framework, you can totally use that as well. It's only called Restify errors because it was extracted from the core of the Restify HTTP framework. But you should definitely check it out. Skip that slide. Cool. So I've got 5 minutes, but I'm probably going to go 5 minutes over. So if you guys want to hang out, that's great. So the last section here, the Great Fire of London. So the Fire of London basically starts as a bakery fire that ends up taking out a large part of central London over the course of 4 days. Now, it could have been prevented fairly early on, but kind of indecisiveness and inaction by the Lord Mayor at the time meant that by the time he made the call, it was really too late to contain the fire. So this makes it kind of a great lead into our next section, which is the problem with try-catch. And this is try-catch as we understand it in JavaScript. And how if you're not disciplined, then it could just lead to the next great production outage of 2017. So I know some of you have been probably nodding along during this entire talk, but what you're really thinking in your head is like, yeah, but hasn't my favorite abstraction solved this problem already, right? Like, I should be able to throw an async context, and it should just work. It doesn't matter if I'm sync or async. Like, I can use something like promises, right? Like, why would I want to go back to callback hell and worry about passing around errors? And that's a really great question. So with all the new ES 2017 features that are coming along, it's true. Like, in the near future, we might be using try-catch everywhere along with async await. So let's take a look at try-catch then. And we can actually really look at it by taking kind of a deep dive at a really simple example here. So we've got a chunk of code here that basically just generates a random number and then says, based on this random number, I'm going to either parse some JSON, right? Or I'm going to attempt to do sort of a addition operation here to a variable that doesn't exist. So what kinds of errors might you expect in the catch clause here? We're actually going to see 2 different types of errors, right? So we're going to see one, which is an expected error, which is you're parsing some input. That input might be bad. You should be able to handle that. Now, the second error here is that bad operation that we just saw, right, where you're attempting to add to a variable that hasn't been defined. And looking at the code, that's not surprising, right? Like, this try-catch is behaving exactly as it's defined and exactly how you've written that code. But the question that I would ask is this really what we want, right? When we want try-catch, aren't we really looking for specific types of errors that we want to handle? Because as we talked about earlier, you can't really catch unexpected errors and handle them properly. So OK, that seems fairly straightforward, right? Like, we can, inside of our catch clause, just catch the errors that we want and then handle it there. But in this example here, I think I'm missing something, right? Like, if I just check for syntax error, which is the JSON parse error, that's fine. I can handle it. But what about the other scenario for unexpected error? That's right. I forgot to rethrow that error, right? And to me, that feels a little bit unsettling, because if I forgot this line, then that means I'd basically be swallowing some errors. So you could make this a little bit easier and then say, hey, I'm going to centralize all of my throw logic, right? Encapsulate all of that logic into a common function, right, that can check if this is the type of error I care about. And if I don't, then simply rethrow it. And that's fine. But to be clear, this doesn't actually absolve the developer of calling your common function, right? It just helps make it a little bit more dry. But that's not the only problem here, because if we go back to our original example, there's another subtle issue here which you may have noticed, right? Checking for syntax error isn't always right? And in fact, it's probably not what we want in many cases, because both of these are syntax errors at some point, but one is an expected error and one is unexpected. So how do we really catch just the one that we care about? Ideally, my solution would be to ask for a language spec change, right? Like JSON parse should probably give me like a parse error or something instead of a syntax error. But since that's not actually a choice, what other options do we have in this scenario? And it turns out we don't really have a lot of options, right? Unfortunately, in JavaScript, try-catch just doesn't give us the ability to really only catch the errors that we care about. So if we look at something like Java again, right? In Java, you can specify in your catch clause the types of exceptions that you care about and want to catch. Now, Java also allows you something called catch throwable, which is like, I'm going to cast a wide net and basically catch everything under the sun. So this includes expected, unexpected, runtime errors, and potentially fatal errors as well. And as we talked about earlier, that's a pretty bad idea, right? Because you can't safely recover from those. And so the reality is that JavaScript's try-catch is equivalent to Java's catch throwable. And so instead, the best that we can really do is just reduce the surface area of try-catch, right? Try to catch only the blocks of code that throw errors that we know we can handle. And so in this case, we keep the JSON parse inside of our try-catch, but then move everything else out. That way, any code with potential programmer errors continues to throw, which nets us our desired behavior of throwing on unexpected errors. So generally speaking, when you must use try-catch, this is kind of the preferred way to go. Be as targeted as possible with your try-catch blocks and make sure you aren't catching unexpected errors. So this is the last section here. We'll talk about promises real quick. So promises have tried to solve many of the problems that we've talked about so far, right? They promise, to let you use sync error handling to, use sync error handling with your async code. Wah, wah. So in practice, what you can do here is basically chain multiple promise operations and just add a catch clause at the end, right? So just like with try-catch, we can basically rethrow on unexpected errors. So we've got this promise chain here, right? But somewhere along the way, something happens. And no problem, let's catch it, right? Just as with regular try-catch, and figure out if we need to rethrow. But does this actually do what we expect it to do, right? If we're saying like, hey, if it's an error that I don't care about, I'm going to rethrow. So if I were to take this actual code and run it on the command line, which I've kind of done here, the output seems pretty correct, right? It looks like the error is being thrown. It's even getting logged out. But you know what? Let me just double check something here, right? Let me get the exit code of that program. So I just want to make sure that it actually did throw. But oh wait, it turns out we got an exit code of 0, which means that this program exited without errors. So despite my explicit throw, the program exited cleanly without errors. So that seems pretty weird, right? And it turns out this is the behavior by design. Promises in their spec have implicit try-catches on all of their operators. So what that means is that if you have errors inside of your catch clause to handle errors, those will get caught and those will get swallowed as well. And so this is less than ideal because it really doesn't work and it doesn't scale. If you're running a ton of Node.js servers in production, there's no way you're going to be grepping through all of your logs for like these random log statements that have been spit out. So that means in order to really get the behavior that you want, you need to call done on these promises, right? So what done does is basically end the promise chain and sort of allow you to escape from the domain of the promise. And by doing so, that allows the error that you've thrown to actually escape from that promise chain and basically bubble up and get you that exit code of 1. So if you're using Bluebird as your promise library, then it's also got some nice sugar for specifying conditional catches, which is actually pretty ideal because this is really what you want. And Bluebird, of course, also gives you a global hook to handle all unhandled errors, where here you can just say, like, if at any time there's an error that is unhandled, then I'm just going to rethrow it and take down my process. So this brings me to my main point, which is, it sounds like I might be crapping on promises, but that's really not my intention, right? Like whether or not it's vanilla try catch or urbacks or even promises, it's less than ideal because it really puts the onus on the developer to do the right thing. And so whether that's making sure we rethrow or making sure that we call done, it's always a bad idea to make what should be the default behavior opt-in. So in the world of software, we're constantly looking for abstractions to make our lives easier. And abstractions that default to shooting yourself in the foot, right, don't really help us become better programmers. And they certainly don't make our lives any easier when it comes to debugging. So this is where I think we can do a lot better to really build abstractions that make it harder for devs to do the wrong thing. So of course, we might start feeling this pain a lot sooner rather than later. JavaScript moving in a direction where promises and async await will allow us to use try-catch everywhere. We'll need the tools to be able to help us differentiate between different types of errors. So while putting together materials for this talk, I found this thread on an old JavaScript board where Brendan Eich made this comment like, hey, you don't need to tell me about this. Like, I proposed some syntax for being able to catch types of errors. It was proposed in 1998, but unfortunately, died with the ashes of Netscape. So never made it out of there. However, there is something new in the 2017 proposals, the ES 2017 proposals, which is what we call refutable pattern matching. And so pattern matching would then actually allow us to easily match against a set of known patterns, or in this case, a set of known errors that we do care about. So while it's still really early days, I believe the pattern matching spec is still in the strawman phase. If this is something that you're interested in or have thoughts about, I would encourage all of you to kind of get on the TC39 boards and give your input and give your thoughts. So the last section is basically just a quick refresher. So I know you guys are ready to go to happy hour, so I'll just go through these real quick. So number 5, use VArrow and rectify errors, right? It should be clear that you can use these modules no matter what your error handling strategy is. And as long as you're working with error objects, then you should be using one of these libraries. Number 4, every async API that ever returns you an error object should either be handled or should be bubbled back up to the caller. Not doing so is the #1 reason for swallowed errors. And if you do choose to use promises, make sure that you're calling done and make sure that your errors are able to escape the promise chain from which they've been defined. Number 3, understand your abstractions. So many times I've ever heard devs talk about not needing to understand how chain callbacks work or how promises work because they're just magic, right? Magic. And I really, really dislike that word. I strongly disagree with that approach because I think so often we talk about using the right tools for the right job. And if you don't understand how your abstractions work, then how do you know what the right tool is? And beyond that, you also need to sort of understand how your abstractions handle errors. So will they swallow them? Will they rethrow them? And what work needs to be done to make sure that they don't violate the principle of least astonishment? So you should have answers for all of these questions every time you start to use a new module. Number 2, as we saw in many examples, it's nearly impossible to recover safely from unexpected errors. So don't do it. In Node, abort immediately, do not recover, do not pass go, do not collect 200. Abort, get a core dump, debug offline. And in the browser, make sure you log that error somewhere so you can report it back to your service at a later point in time. And number 1, the final but most important thing, please, please, please design and build applications with error handling in mind. Contrary to popular belief, you can't tack on error handling at the 11th hour. They must be part of the design and spec from day 1. And in fact, attempting to add error handling at that 11th hour and adding it so late in the game typically only makes your application more brittle. So everybody knows how the Titanic went down, right? As it turns out, you can't just phone in your emergency plan and call it a day. So the name for exceptions really originated from the idea that they were exceptional. But as any programmer knows, the more programming you do, the less exceptional these scenarios become. And if anything, unhappy paths are frequently traversed just as frequently as happy paths. So that's pretty much all I've got for you today. The rest of my slides are just really links to a ton of the stuff that I've talked about today. So the bit.ly link here will send you to my slides if you care to review them. And that's pretty much all I've got. Feel free to come up and ask me questions if you got any. Thanks, guys.